Hello, everyone.
Good morning. How are you doing?
Good morning, Professor.
Hello, Cameron.
Hello, Professor.
Until the rest of our group shows up, I am gonna show you the file I made with, of course, I have here my quartz. This is my VHD file. No, this is my VHD file. It is very simple. It is not gate, and I have generated the VHT file. And
Professor, we can't see your screen, sorry.
oh, okay. This is my, again, VHD file. It is just simple, I have nothing. And this is my VHT file. I generated it using the quartz, using the tools. I use the tools here. And start simulation processing. I use this start self test bench template. I have this, and I put only this line. Pin is high, wait, pin is low, pin is high, wait, and that's it. I added this file to the project, and I went to the setting. It is VHDL, and I have it as a test bench. I added it as a test bench. Now I believe I am ready to go to tools. Correct, Cameron?
Well, make sure you compile it with the Quartus compiler first.
I did.
If you did
Okay,
that already.
let me compile it again, no problem.
I think it's always good to double check that.
Yeah. I believe it is done. And my messages.
Yep. So now you should be able to run the RTL simulation.
Okay. It seems that it did recompile and did everything.
So sometimes it'll try to compile some weird file. I don't think that's what you want. I think if you go back to library and go and recompile from the work file. And recompile the test bench, that TST.
This is the test bench.
Recompile. Yep. And it looks like 0 errors. Okay. and then right click and simulate.
This one?
Yeah, right click the test bench again and press simulate.
Where is that? Oh, this
On the
test bench.
highlighted thing.
Okay,
You
okay.
right click the highlighted test bench, yeah.
Yeah, and simulate. Okay.
Yes, yeah. You should. And then press the little plus at the top of that that screen there.
Yeah.
And then on I1, if you press that and right click it and then press add wave.
This one?
On I1, the one below it. Yeah.
Add wave.
Mm-hmm. And you should see in your waveform generate or in your waveform over here. If you go over to the screen with waves.
This one?
Yep. There you go. There's your inputs on there, and then so you can set your time to whatever time you set your stop time to be, and then run it.
Run it here.
Yes.
I have nothing.
You have to press the little piece of paper next to it.
The one? This one?
The one to the left.
This one? I did.
Yeah. You click that.
Okay.
Maybe try zooming out. There should be something there.
Zooming in.
Because there's a little.
I go to view. I can go to view.
There should be a. You want to zoom out though, because generally it's too close for that. So let me click that. Isn't there the little maybe make the screen full screen because it looks like part of your screen's off here. Yeah, there's your little magnifier glasses. So just press the magnifying glasses. And you want to zoom out.
Oh, here we
Oh
have.
yeah, there you go. There you go. Yeah, you got it.
So it is running perfect.
Yes.
Okay. After we finish, I'm gonna go through it from the beginning. I'm gonna erase all files and I'll let everyone to share this with me. And I'm gonna send you a copy or view. Okay. Now I'll stop sharing. Hello, Vitali. Vitali?
Good morning, Professor. Yes.
Good morning. How are you today?
I'm doing just fine. Thank you, sir.
Great.
How about yourself?
Just fine. Thank you.
Very good.
Hello, Bernard. Hello, Bernard.
Good morning, Professor.
Good morning. Okay, let's start our lecture or continue our lecture. We stopped here. We are gonna go over it one more time. It is first in, first out. Hello, Jim. Jim,
morning.
good
Good morning.
morning.
Good morning, sir. Little slick out this morning.
Oh, really?
Yeah, there were hills where cars were stuck all over and I couldn't get by.
Okay. Here we have 8-bit, and those storage, I have write counter and read counter. Whenever I write something, the write counter will jump up. When I read something, the read counter will go up. Meanwhile, it will empty whatever was there or mark them as empty or ready for reloading. Okay, I am gonna write 4 bits, 1, 0, 1, 0. And after that, my write counter will be pointing to here, pointing to this one. I am ready for this one. So it moved in here. Whenever you write, you are going to start writing from this slot 5. Now my read counter is going to read 2. So it's going to read 1, it's going to read 0, and will be ready for the next reading that will be in here. If I write 3 more digits, what will happen? Write 3 more digits. I'm gonna write 1, 0, 1. And the write counter will jump to be ready in here. Suppose that the read counter is gonna read 6. What will happen, Jim?
It'll write in 6, or it'll read in 6 things, and the green arrow on the right will move in up 6 locations.
Okay,
1,
just
2,
tell me
3,
where should I
4.
put the green arrow, or what data that will be read? Tell me 1, 0, 1, 0. What data will be read if I read 6?
You'll read 1, 0, 1, 0, 1.
Waiting for you.
And can you not hear me?
No, I hear you, but the last one.
1, 2, 3, 4, 5, and I'll go back to the bottom
No,
where
no. I am here. That is 1, 2, 3, 4, 5, 6.
there's nothing there.
Oh, yes,
So
there is
it'll read
nothing
trash.
there. So it should give me a warning that this slot is not ready. Any warning, red flag, anything. And as a matter of fact, what will happen if I read 5? 1, 2, 3, 4, 5. It's going to read 5. But again, it should tell me warning. The coming read is empty. Be careful. And sometimes it is ahead of time. Here, before it, sometimes I can program it to tell me after the second read, you are gonna hit an empty slot. Be careful. The same thing for write. When you hit the end, it should go back. And suppose that I haven't read anything. When I go back in here, it will give me a warning. We are gonna overwrite. I am gonna overwrite. Those are flags, very important flags. Now let's go to our slides. Is it clear, Paige, what I said?
Yes, if you keep on explaining, I think I will get it better.
Okay, we'll go back, no problem.
Oh, I understand what you're doing up until now. I just
Okay,
want you
okay,
to keep on explaining.
okay, okay. We spoke last time, we said that this is the read pointer and the write pointer, everything is free. If I write one slot, my pointer will move, pointing to the coming empty slot. If I write three more, 1, 2, 3, I'm gonna be pointing at slot 5, that is number 4. And if I start reading, I am clearing whatever was in here for coming right. Now I did 4 writes. I was here, 1, 2, 3, 4. Now I am pointing at 0. One more write. I have no place, no more writing, unless you are gonna overwrite, unless we have a read to clear it. Lucky enough, we have 2 reads, so I can write onto these 2 slots. And 5 more reads. Oh, I finished everything. Now, after one more read, I am here. As I said, we need some flags. Those are the pointer. Do we all understand how the read and write pointers move? Vitali?
Yeah, so I guess just the one thing that I'm a little confused about is in that last example when you had an empty data and you had to read 6 bits. What exactly happens? Like, is there an error?
You'll get a warning because
Warning. Oh, okay.
you haven't written it yourself. There could be any number over there, not the one you are looking for. So
Gotcha.
we'll get a warning.
And so the read and write just follow each other then, right? Like if you have a read, then you have to write it, and so it'll follow those.
You have to finish writing first and start reading afterward.
Oh, okay. So
If you read more than the write, what will happen? There is no data to read, so you'll get a warning. It might be the data from previous runs. It can be anything, but it's not going to be what you are looking for. It is not going to be whatever is written by the write pointer.
Yeah, that makes sense. I got you.
Okay.
Good question.
Okay.
On when you are reading, is it only the write that erases? I'm sorry, is it only the read that erases the memory? Or does it write?
It doesn't erase the memory, but it is marking it ready for another write.
Okay, so
I have this data safe with me now. We got the data you wanted to transfer to us. We received it. So we are ready for another data in.
okay, so data have not been read.
No.
Right over it.
No. It is gonna say just this memory spot. The data, we acquired it and we have it. We are happy with it. And you may use this memory slot for another write.
Thank you.
We have empty flag. If read pointer and write pointer pointing to the same thing, that means the next read will have nothing because they are on the same level. The next thing, it will be empty. So we'll get empty flag. Almost empty flag, usually 1. That means write is one slot ahead of me. If I hit it, I'll get data, but be careful. The next one, it will be empty. So it is almost empty flag. I can program it. I can say before if the write is ahead of 2, okay, give this warning, but I can make it 1. Full flag, that means read equal write again. Read equal write. So unless you read something, the next write will be overwriting whatever is there. That's why it is called full flag. You can see here empty flag and full flag may both come on at the same time. May both come on at the same time, because the empty flag says the next one will be empty, because read and write pointing to the same point. If read moves, it will read empty. Again, full flag. If write moves, it will is gonna overwrite whatever is there. So both flags can be at the same can come out simultaneously. Almost full flag. I am one slot behind completing my full data without any read. This is when I get this flag, almost full. Data count is what? I have up-down counter, and this counter can count up to 8. If I write, up counter will increment. If I read, down counter will decrement. Reading, writing, go up, reading, go down. Okay, so I can see where I am exactly. The pointer, where is reading and writing? Where am I on these 8 slots? This is first in, first out block diagram. This is my memory, 4096, and the width is 32. 4096, I can write, I can read. Means data may come in and data may come out. You can see here the data is 32-bit, 32-bit. This is my data. And my address pointer, it is 12. 2 to the power 12, 4096. I get my write command. What happens here? Write enable, okay. And the pointer will go up. And the data will be transferred from data in to the memory location. One more write. Write pointer will go up and new data come in. Each time I have a write command, I write my data and I increment my write pointer will go up. What will happen if I have full memory with no read at all? I will get here a flag that says it is memory full. And this flag will raise full. Now I go to the other side. I am issuing here a read. When I issue this read, the read pointer will read whatever is here and put it out and increment. One more read whatever is here, put it on data out, increment, and so on. During that time, as I did on the left-hand side, on this right-hand side, each read will decrement, will say countdown 1. And if I have reached a flag, it will initiate this one. That means I have read everything. I have nothing. The coming read will read nothing, will read unknown data. That means empty. I finished reading all of my memory that was written legitimately by the right command through the data in. If you do any more read, I need a flag. So this flag will come in here and will raise the flag empty. So the up-down counter is very useful for the flag. Any questions? Cameron?
Yes, Professor.
Clear?
Yes, it's clear to me.
Okay. Jose?
No, no questions, Professor. Thank you. Those diagrams are pretty good.
Okay, so I should continue then?
Yes, please.
Okay. This is an example. It says, I am giving data in and I am giving data out. But data out here, it could be slow, slower than the data in. Okay, this is my data in and this is my data out. Or the requests for data in, and those are the requests for data out. This is a time diagram. Here I've started pushing data. My up-down counter will go up very fast. Starting at this point, I'm still putting data in while taking data out. When I take data out, I am taking it at a slower rate. That is why I don't have this fast movement. No, slow one. Why slow one? Because I am giving data in while taking data out. What's happening here? I'm not giving any data. I am just taking data out. So I am moving at the slow rate until I reach 0. When I reach 0, lucky enough, I have here more data coming in while not taking any data. Okay, so I'll move fast. Then here I will start giving data in while taking data out at slow rate. The same slope as I had here. Finally, I am collecting my data. I'm reading all of my data out until I hit 0. Is it clear, Jim?
It is clear.
Okay. Clear, Vitaly?
Yes, that makes perfect sense.
Okay, thank you. This is a complicated state machine, not very complicated, but not easy one. I have analog to digital converter. This data, it is 24-bit. And I am gonna do some math on it. And the data coming out will be 32. So my A to D was 24-bit, but after doing the math, it is 32-bit. So I have this state machine. This state machine, it is controlling the data. Now I have data. I am ready to write it to first in, first out. And I will get a warning from first in, first out if I have here full. I didn't read anything. So you keep on pushing data, I will get a warning that it is full. It will feed this state machine. Now I have this first in, first out. It is going to give data to another mathematics, binary math, another mathematical program. This one. This is taking 64-bit. So it's going to take 2 of whatever you saved in here. Each grab will grab 232. Okay. We have it in here. And it has another state machine. It will go to here to read, to get data. And if there is no data, it will get a flag saying empty. But this binary math, after doing the binary, it is going to feed an output to another first in, first out. So I need for this machine to be big enough to write also, to command this first in, first out for writing. And this one, when it is full, it will flag it. Finally, this data will go through some mathematics to come out as a 32-bit. So it's going to be converted from 64 to 32. And this state machine will read whatever in here. And when the first in, first out is empty, I will get a warning empty. Hello, Paige? Hello, Paige?
While we're waiting for her, can I ask a question?
Yes.
On the far left, we have, bottom left, we have a state machine and a first in, first out. Is
Yeah.
that the WR, the right, the
Yes.
arrow that goes to the right?
Yes.
Is that just a permission to write?
No, it is a right pointer.
Okay, that's the pointer itself. Okay.
Yeah. Yeah.
Okay. So the one on the left then would read the read pointer. I got it. I mean
Yes.
on the right. Yeah. Okay.
Okay.
So the state machine is what change, the state machine's what changes the pointer
And
and tells
the
the
state
binary
machine,
map to go
it has the counter. It is when it goes up, when it writes the first in, first out. This is the first in, first out. This is a complete first in, first out.
Right.
It takes the write command from here. And this is the write. And it takes a read from here, read command. So here I have a write command. The state machine has the built-in counter. It has the pointer. It has the flags to send. So all what I do here is write. Tell the first in, first out, I need to write. This is the one in similar to this.
Okay. I understand now.
Okay. Clear, Vitaly?
For the most part, yes.
Okay. I believe that is the end of this lecture. I'll go back to our assignment. We have 3 parts, as we discussed yesterday, that will be working on them. Part 1, we have 3 examples presented in the lecture. Example 1, this is the ROM. Example 2, this is the RAM. Example 3, parameterized RAM, where I used generic. So part 1, I believe you are done with those. So part 1 is ready. Part 2, for the parameterized, I have used a default size of 256 by 8. So I changed the parameters in here. And you can use the test bench, you can use waveform generator, whatever you like, and include the waveform. Part 3, here I am gonna be writing text to the memory, but I am not writing ABC. I am writing the equivalent ASCII code. It is zeros and ones, but it is equivalent ASCII code. And here we need this part to write this data to the ROM. First, as we have here, written this data to the ROM, I will write this text to the ROM, and it will include carriage return, it will include new line, and that's it. All those 3 parts. Any questions? Any questions? If not, I will go with test bench. I am gonna show you how we can do a test bench in a very simple way, and Cameron will be my guide. But please, the recording, you can watch it over and over and no problem. Okay, now I am having this, it is closed. I'll close it. We have nothing. Yes. We have nothing here. This is my folder that was running. I hate to delete it, but I will. Now I lost it. Done. I will start chords from scratch. You may write down the steps that you don't know. New project. This is my folder. Project name, TT1. Select my processor and the parameters. Now I'm gonna start a VHDL file, empty one. This is my file. It is just a NOT circuit. Compile it. Oh, I need to save it. File. Save as. It is TT1. Control L, compiling. While it compiles, I'll grab the next one. Now I finished this one and I have no errors. I go to assignment, settings. I need this to be VHDL, model sim Altera. Now I will go to my processing, start. This is start test bench template writer. It will write a test bench for me, the template for a test bench. Now I go to open file. I want to see it. Where is it? It's going to be under simulation, under model sim, but there is nothing. So I need to show all files. This is the VHDL template, VHT. This is the file I want to get. Here is it. It is ready with all component, with all signals, all what you need to do as it says here. Code executed here. So I wrote this code. It tells pin name 1, 0, wait 100 nanosecond, then move it to 1, wait for 100 nanosecond. I don't need to wait. And I will save this. And I will compile it to make sure it is correct. I believe it is done and we have no errors. This is my VHT. I have 2 more steps before going to the simulation. The first one is to add this file to my project. Now it is added to the project. The second one is for setting to include this simulation file that compile test bench. I go to new. Where is it? We know the location. Under simulation, model sim, this is the VHT, open. And it needs a name, TT1, the same name, add, okay, apply, oh, new, yes. What is this? Cancel.
Just hit OK, Professor. Yeah.
Apply, okay. This file was added to the project and I added it to my system through settings as a test bench. Now I am ready for run simulation tool, RTL simulation. It is running in the background. Let it finish. When it is done, I go back to library, expand the work subfolder. Here is my test bench. I need to recompile it. It is recompiled with 0 error and 2 warnings. If I go back to this file here, right click, and I tell it simulate. Here, this I1 I need to add it to the waveform. Add to the waveform. I added it to the waveform. This is my waveform. I have input and output. This one, picosecond. I want to have nanosecond. I'm not going to go for long, just 400, because my system, it is 200 milliseconds. So I have chosen this one. Now I am ready to run. And let's expand this. And we need to zoom out until we see something. Zoom full. Yes, this is better. Now I have my change, not if this is low, output is high. High, output is low. Working perfect. Okay. I will stop sharing and I'll let you work on your assignment. Okay. Thank you. I may share the screen as needed.
Thank you, sir. The test bench thing helped.
Professor, please, can you post this today? Professor? Hello? Professor?
Yes, sir.
Yeah, please, can you post this today on your website?
Yes, of course. Of course,
Thank you,
as
sir.
usual.
Thank you.
Okay.
Professor, I have a question for you. Okay, guys. So he has lectures next week. He doesn't mean that, right?
Sorry, can you explain that again?
He has lectures posted for next week, like times. The we're done if we just complete those assignments, right?
I want to say so. I think that they're just there because when he like started the course and he like set the Zoom calendar, it like goes to the very end of the term, which by technical definition is like the 16th Friday.
Right.
But
Okay.
I doubt we're going over the material after this is the last assignment. Yeah.
Well, that's what I was thinking too, but sometimes he surprises me.
Excuse me, this is Ballard. He can't really hold lectures because people during those test times can't be here.
Right. I just didn't know if he was planning on doing it.
But he could lecture during his own test time
Right.
or answer questions, hold the class and answer questions.
Okay. I just didn't know if he was planning on it and just didn't think about it or what.
The moment he hops back on, we can ask him.
How is it going? Hello?
Going well.
Good, Professor. Professor, there was a question.
Okay.
So it says that next week you have lecture scheduled, but we were wondering if this week is the last week of lecture, or how is it going to work?
Isn't this week then?
Yes, sir.
Okay, so no lecture next week.
So are we going to have last lecture on Friday or something like that?
Friday will be quiz 4.
So last class is tomorrow then, yes?
Yes.
Okay, very good. What kind of cookies do you want me to bring you?
I missed it.
Please
Okay.
tell your wife thank you from Circuit 1. I'll never forget.
Okay. I hope we can take a group photo tomorrow.
Sounds good to me.
Okay. Jim?
I'll bring donuts.
No, you bring your tie.
So do you
Suit
want,
and tie. Yes, it is formal photo.
I see. I'll wear my suit and tie.
Okay.
I haven't had them on since,
Since
I
your
don't know,
marriage.
my last funeral or something.
No, your last marriage.
That's been some years, fella.
Okay.
So do you want to meet during test time?
No.
Okay.
Okay. How is the homework assignment going? Part 1 is done?
Yes. Well, most of it.
Okay. We'll continue it. And as I said, you may share screen at any time.
Okay. Thank you.
Thank you. Hello? How is it going? Vitaly?
Yeah, I just had one issue where I had to recompile my parameterized RAM, but I just fixed it. So yeah, I'm adjusting it for part 2, where
Oh,
it's a different number of bits. And so yes, I'm working on that part now.
okay, okay.
But going well, so thank you.
Yes, Jim?
Going well.
Oh,
I need to run to the lab and stuff, so I'm gonna sign off if you don't mind.
no problem at all.
Okay,
Anybody who wanna leave, you are free to leave, no problem at all.
thank you.
Thank you.
We'll see you tomorrow.
Yes, we'll meet tomorrow. Thank you.
Okay, so have a nice rest of your day, Professor. See you tomorrow.
Okay, sir, no problem. Anybody who wants to leave, feel free to go.
Thank you, Professor. See you
Thank you.
tomorrow.
Thank you, Professor.
Thank you all. Thank you all.
Thank you, Professor. See you tomorrow.
Bye-bye.